Okay, so I got another one of these Inkbird controllers, and I kind of accidentally got a VH model, which means that, I think it's VH, is that what this one is? Yeah, doesn't say on the box, it says on the side. Yeah, 106 VH is what this one is. So that means that it doesn't have, the output is not a relay, the output drives, it's a DC voltage that drives a solid state relay. So that's not really what I wanted to use for this, because this is controlling my ashing solenoid relay and my auger motor relay. So basically I have a relay like this, you know, it's a Honeywell one that is 24 volts, and it switches the power off and on from the auger and the ashing solenoid. So, I mean, it's little thermostat wire that you use. So it's little amounts of current. It's 24 volts AC, so it's not much of anything. So I found on eBay, I think this was $10 for a bag of 5 of these. These are automotive relays, and you can see they're 12 volts. 12 volts means this coil that activates it will activate on 12 volts DC, which is exactly what this puts out to the solid state relay if you're using the solid state relay. So essentially these are the same thing on the activation side. This is meant for DC though, so it wouldn't be good to use for, you know, 120 volt AC stuff. But since we're only doing 24 volts AC and very low current, we're going to go with it anyway. It'll probably work fine. So this is our little test setup. The set point right now is at 100 degrees, and what they're calling the hysteresis is set at 5 degrees. So that means it's going to be within 5 degrees of this 100 degrees Fahrenheit that it's trying to maintain. So if I heat the sensor up, the relay, you can see the ohm meter's 0 right now, or infinite right now. There you go, it clicked on. Now the relay is closed. So this is going to be my exhaust gas controller, which will inhibit the ashing below certain exhaust gas temperatures. I mean, ideally it'll be like 180 or 190 degrees is what it'll be set at. So you can see as this drops both down to 95 degrees, the relay will open again. We could hurry that on along. Well, we don't really need to hurry it on, do we? It'll be there any second. And once you hear the click again, you'll see the meter go to open. There you go. Now it's open. So yeah, this should work pretty good. I mean, this was a bag of 5 of these relays for, I don't know, it was like $10 or something like that on eBay. So I'm pretty happy with that. I'm going to go put it in there and see how it works. Okay, so we got the right one wired in here now. That's this one. I have the set temperature set at 180 degrees. So that means the ashing should stop. Let me turn it on here. There we go. So right now this is below the set point. So when this reaches 185 with our 5 degree hysteresis, it will allow the ashing solenoid to start ashing. It's been off for a while while I was doing this, so it's going to take a little bit to catch up. The boiler temperature is down to below 140. So yeah, once this all gets warmed up, it'll start ashing when these two are together. Right now, this is saying, yes, please ash. This one is not. And because this guy is on, it's below the set point, this is turned on its solid state relay here. So you can hear the fan running. But no ashing is happening yet. And I just have our relay sitting back here. So, we'll come back a little later when it's all working. Okay, so it's running along here. The one problem we have is this is reading about 70 degrees lower than our barbecue thermometer here. So what we're going to do, we'll go in here. Oops, not there. Operation. And we'll check. Maybe it's there. Dig through these menus to see where it is. Okay, it wasn't in that one, so it's probably in the alarm menu. Zero, high alarm, low alarm, D high alarm, D low alarm. Diff, that's the hysteresis, which we already set, 5 degrees. Display on. Okay, wasn't that. Oh, it's in the PID menu. Control 4. P1D. Yeah, no, it's not in that. Okay. Where is this? Operation. Nope, been through here. Must be in the first one. First menu. That's the sensor. SC, 0 degrees. Okay, so that's SC is the correction factor. So we are going to add 70 degrees and see how that goes. Ooh, there we go. Kind of startled me a little bit. So there it is. It says 242 degrees right now. And what's our barbecue thermometer say? It actually says 40, 50. That's like 239. If I read that correctly, which, yeah, we're within a couple of degrees. So we'll call that good. All right. Well, there it is. It's running. Doing its thing. Cleaned up the fire view door. So you can see the burning coal in there. Pretty crazy looking stuff. We're still running the low and slow setting, so the fire doesn't really get super lively or anything. It just cooks. And with these things, once it shuts off, it still cooks. So it can actually satisfy a heat call if it was off. So that's kind of interesting. So we'll leave these control settings for a while and we'll see how they go. It is. See, it's an Axeman Anderson, made in 1959.
130,000 BTU per hour.
Coal-fired anthracite burning boiler.